Pick the graph of the following function. So you could graph this on your calculator, but to be honest, you will take more time in setting up and graphing than you could be done with the problem. So for instance, it's already in factored form, so we can very readily see the zeros of the polynomial. And the zeros here are 0 itself, coming from the first 0 there. And then x minus 2, if we set that to 0, we get positive 2 as a 0. This is multiplicity 1, so what happens is the graph just passes through at 0, and it touches the axis and bounces back away at positive 2 because we have multiplicity 2. So at positive 2, that's not happening in this particular graph, so we can already throw out this possibility. This graph doesn't even have a 0 at positive 2, so we can throw out that possibility. It only leaves us 2 here, and to be honest, this one doesn't have a 0 at 2. This is our only option left. Just to make sure everything else works out, we have the 0 at 0 and 2, and this one's multiplicity 2, and this one's 1. The only thing that's left to determine is the end behavior of the graph. There are 3 total zeros. If you add up all the multiplicities, that gives you the total number of zeros. And if you think about a degree 3 polynomial with a leading term coefficient that's positive, that's going to start in the negative direction and end in the positive direction, which is exactly what's happening here. So this is certainly the graph of our polynomial.